we're going to talk about next-gen device fingerprinting, why that is critical, what the difference between next-gen device fingerprinting and legacy device fingerprinting is, and how that can affect your cybersecurity plans. So obviously, one of the things that device fingerprinting is used for is to detect and fingerprint unknown devices. So unknown devices are part of the picture. What we find is that devices that are end of sale and support or have vulnerabilities are really the crux of the pain point for most cybersecurity professionals who are dealing with devices connecting to their network and attempting to mitigate the risk of those devices and determine what to do with those devices. So an easy way to highlight that is to discuss some of the high profile scenarios that have occurred in recent times. So the NASA Jet Propulsion Lab data breach was actually caused by an unauthorized Raspberry Pi device connecting to the network that the IT staff did not know about. Once they did subsequent audits, they actually found a bunch of other devices that they also did not know about. So the first category that we talk about, which is unknown devices, not knowing that they're there, legacy device fingerprinting can do an adequate job of identifying devices, but really that only paints part of the picture relative to what we need to be concerned about with regards to devices and what types of devices and the status of those devices when they connect to your network. If we talk about specific vulnerabilities, another high-profile one was the Equifax breach. So there was a particular device that actually had a vulnerability that was exploited. So this is where legacy device fingerprinting really doesn't get the job done. You're really relying on a separate system like a vulnerability scanner generating reports, and that has to be analyzed to be able to make that information actionable. So you have to know that devices are on the network. You have to know if they're vulnerable, and you have to be able to do something about that. Additionally, end of life, end of sale, end of support devices are a huge concern. Even Cisco Systems, comments on how most organizations have no idea what's really out there relative to end of life, end of support, and whether those devices are actually supported and patched and up to date. And further echoing that sentiment, the Online Trust Alliance, their most recent study found that there was 2 million cybersecurity incidents totaling in 45 billion in losses in 2018. That's not that in itself is an issue, but the real problem is that 95% of those were avoidable. So there's several categories that and several root causes that can be addressed, but two of the ones that keep coming up over and over again is that devices are end of life and thereby unsupported, and they're sitting on the network. And then also, even though there may be vulnerability scanners that organizations are using, there's no good way to process those huge reports that may be thousands of lines long and to take action. So having multiple systems, having to identify your assets, what is end of life, having to identify devices that may have vulnerabilities, that is the challenge. So that is why it is important to have this information. Aside from that, it's really just a best practice. So across all the different regulatory compliances, the Center for Internet Security has identified basic controls that should always be adopted. So yes, there's a lot of horror stories out there and it's scary, but also these are just best practices and they should be followed. So throughout the course of our webinar series, we're going to be talking about all of these different controls. This particular webinar is going to focus specifically on knowing what types of devices and assets are on the network, and then also being able to manage the vulnerability of those devices. In subsequent webinars, we'll talk about some of these other controls, but today it's really going to be focused on visibility, vulnerability, and being able to identify devices on the network properly. So how does network access control correlate with these core cybersecurity requirements? What we've done here is we've correlated the core requirements to network access control features. Um, Specifically, inventory of hardware and assets on the network access control systems, most of them can detect all IP-enabled devices on the network. Whether or not they can identify the very specific platform, we'll talk a little bit more about that in the upcoming slides. Also, being able to continuously manage the vulnerabilities, that is a more challenging piece. What we'll talk about today is how a product called DPI with Genie and Znack can actually link devices that have been detected and then link those with known vulnerabilities and also identify whether those devices are end of sale or end of support.